Welcome to our mathematics class. We want to look at the topic in Form 2, indices. Specifically, we want to look at the laws of indices. We have two objectives, and the first one is to see how we raise a power to a power, and the second one is to explain fractional indices. Let's go to the first objective and see what we can say about raising a power to a power. Now we want to base our discussion on the law that we discussed last time. A raised to x multiplied by a raised to y gives us a raised to x plus y. Now we ask ourselves, suppose a raised to y was also a raised to x. In other words, we would be squaring a raised to x. That is a raised to x squared. And this would be a raised to x multiplied by a raised to x. And according to the law, that would therefore become a raised to x plus x, which is a raised to 2x. If we now extend that further to, for example, a raised to x raised to 3, we can follow the same pattern and have a raised to x times a raised to x times a raised to x. And this would mean, therefore, that we add x to x and then to x, and this would give us a raised to 3x. Now, suppose we wanted to raise this a power x to any other power, like 4, 5, 6, and so on. In other words, suppose we had a raised to x raised to any number, then it would mean that we would go on like that. We would have a raised to x, a raised to x, like that. And from here, when we raised to power 2, the result was 2x. When we raised to power 3, the result was 3x. We can therefore conclude that when we go up to n times, then this will be a raised to nx. And therefore we can generalize that if we have a raised to x and we raise it to y, then all we need to do is multiply x by y, like we have done here. It was a raised to x and we squared, so the final result is 2 times x. 2 times x, or x times 2, whichever way you want to look at it. And therefore, a raised to x would be the same as a raised to x y. And this law, therefore, gives us what to do when we are raising a power to a power. Let's look at an example. We have been asked to simplify that, and if we follow our law, then the working is very simple. We will simply multiply 3 by 5 to get 2 raised to the power of 15. Let's now go to our objective number 2, where we look at fractional indices. In our last lesson, we also explained what we meant by x raised to the power of a half. This one we found to be equivalent to the square root of x. 2 is not normally written here, but when we go to higher roots, we will write, for example, x raised to the power of 3 will be written as cube root of x power 1, even in this case, power 1. From the square root of x, and now what we have given here, the cube root of x, there seems to be a way in which we can understand where the 1 is in the fractional index and where the 3 is. In general, whenever we have x raised to the power of 1 over y, from these two, we can see that y represents the root, and the numerator here, which in this case is 1, represents the power to which x is raised. The same can be moved a little bit further, where, for example, we square or cube x power half, and then we apply the law we have just done here. Suppose you are given x raised to the power of a half, and we are asked to cube this one. From the law we have just looked at, a raised to power x raised to y becomes a raised to xy. Applying the law, therefore, we will get x power half raised to power 3 is the same as x raised to power 3 over 2, because you can multiply a half by 3. From there, therefore, we can see that what comes to the numerator is the power. And so we can understand that x raised to the power of 3 over 2 means the square root of x raised to power 3. For your homework, simplify 2 power 3 raised to 4 and explain what we mean by how we can write this in fractional form, where we have the fifth root of x squared. Write it in form of a fractional index. We are going to stop there. Remember to subscribe and also share the link in this case, so that you'll be notified when we'll be discussing further on this topic and many more.